Hello dear students, I am Dr. Deepak Kumar, Associate Professor in Department of Mechanical Engineering, SKIT Jaipur. Today we are going to discuss the topic of Taguchi method, which belongs to Unit 5th of the Quality Management subject. The content of this lecture are Introduction, Robust Design, Quality Loss Function, which has three cases: larger the better, smaller the better, nominal the better, signal to noise ratio, example and conclusion. Introduction of Taguchi method. Taguchi was an electrical engineer of Japan and who given the concept of robust design. The goal of quality engineering is to move quality improvement efforts upstream from the production phase to the product or process design stage. It is the method of offline production system as suggested by the Taguchi. He given the concept of loss function. According to him, the main concern is deviation of a characteristics from its nominal value. As we know that characteristics means it may be the diameter of the piston. So how much it will deviate, there will be loss regarding the assembly. There are certain uncontrollable factors which are known as noise, which are generally responsible for this deviation, and we want to design our system as robust system. So we can see this is a system having the input and output, which is known as response, and there are certain noise factors which may be noise or vibration, which we don't want to control, or it is costly to control them. The other factors are control factors which we want to control. For example, in a CNC lathe machine, we want to control the feed, depth of cut and cutting velocity. So with the help of these parameters, we want to control our response, which may be the good surface finish of the product. Taguchi loss function definition is, according to Taguchi, the loss imparted by the product to society from the time the product is shipped to the customer. Loss is regarding the cost to operate, failure to function, maintenance cost and repair cost, customer dissatisfaction, poor design. Taguchi suggested a three-stage design process. First is system design. Create prototype product and process to produce it. It is the innovative process by which we can produce some improvement in the system design. The other is parameter design regarding the tuning of the process parameters. For example, the CNC lathe machine, we can tune the feed, depth of cut and cutting velocity to obtain the good surface finish. So this is the parameter design. Similarly, the tolerance design, which is the trade-off between the loss to consumer and manufacturing cost. Now there are three cases of quality loss function. These are LTB, means larger the better. For example, agricultural crop yield, smaller the better. For example, the pollution, that is the carbon dioxide emission and defects. Third one is the nominal the better. It means if the component is on the matching, then there should be the minimum variation. For example, in the piston cylinder assembly, the variation should be minimum. So we can see the larger the better. A larger value is better. For example, in a fuel mileage, it may be in the distance per liter. Second is the smaller the better. A smaller value is better. For example, the vehicle emissions in rupees per distance, fuel consumption in rupees per distance. The third one is the nominal the best. The nominal value is best because it is one that satisfies the customer's need. The characteristics value away on either side of the target is undesirable, such as air pressure in vehicle tires. If the air pressure is high, it is loss to the customer. If it is low, then again loss to the customer. Now in the mathematical form, The Taguchi method is larger is better case, L is the loss to the customer, Y is the characteristics, K is the proportionality constant. So we can see if the Y square is more, then loss will be less. So this is the case of larger is better. Like vehicle mileage is more, Y square is more, then loss will be less. The second case, smaller is better. The defects are less, Y square is less, then loss will be less. Third one is the nominal is best. Y minus M shows the deviation. So deviation is less, then loss will be less. So we can see here the loss function. If the variation is less, then there is the value of the loss will be less. So we can see here. So now in graphical representation, larger the better case, as shown in the colored line, the performance is as high as, then the loss is on the y-axis, it will be less. Like fuel mileage, the second case is smaller the better. If the y square is less, then loss will be less. Like defects, in casting we want to reduce the defects. Third one is the nominal the better. If the deviation is less, then the loss will be less. It is shown by this colored line. If we will move in the right direction or left direction, which shows the more variation, then there will be more loss to the customer. Now Taguchi given the concept of signal to noise ratio. According to it brings the effect of input parameters on a single scale. By these formula we can calculate the signal to noise ratio for the different three cases we have discussed. We can see one example here. Suppose there is a plastic injection molding by which we can produce the plastic parts, and there are 6 parameters: mold temperature, melt temperature, injection pressure, packing time, packing pressure, and cooling time. These are the 6 parameters. Mold temperature, suppose the range of mold temperature is between 60 to 80 and the unit is degree centigrade. Similarly, melt temperature, the range is 235 to 275 in degree centigrade, and injection pressure is varying between 110 to 130, unit is megapascal. So each parameter has its own range and units. So with the help of signal to noise ratio, we can see here, if we conduct the 9 experiment, so A, B, C, D, E, F, these are the 6 parameters we have seen, and we want to calculate the shrinkage, which is the defect, as response of the plastic part. So we can calculate its signal to noise ratio, and we can bring the effect of input parameters on a single scale. So we can see the signal to noise ratio is in these negative values, -18, -17, something like this. So on a single scale we can bring the effect of these input parameters, which help to determine and to bring the improved quality. So as a conclusion, we can say the quantification of quality through quality loss function has been performed by Taguchi method, and when a product moves from its target, it will cause the loss even if the product lies or not within the limits. Taguchi suggested the concept of robust design and given the concept of signal to noise ratio, by which we can bring the effect of input parameters on a single scale. Thanks.